Alright, we're going to take a look at the labs basics key here. So labs basics key. In this case, we're basically going over basic lab type materials. So the first question here, we're given presented a reaction, 50 milligrams molecular weight, milligrams per mole or millimole, A and B, 50 and 100 the molecular weights going to C. So it's a hypothetical situation. The first question asks us, we have 25 milligrams of each of the two reactants. Which one is the limiting reactant? Must show your work. So in this case, you need to convert your milligrams to millimoles, right, to find out which one's the limiting reactant, which are the least amount of millimoles. So if you take the molecular weights, 25 grams of A, molecular weight can be given in 50 milligrams per millimole. You're probably used to seeing grams per mole, but if you do milligrams per millimole, it's the same deal. So milligrams cancel out, and you get 0.5 millimoles of A. If you did B, molecular weight's 100 milligrams per 1 millimole, 25 milligrams of B. Cross out, get 0.25 millimoles of B, so the less amount is the limiting reagent, so that's B in this case. Next question, B comes in a 5 molar solution. How many mils of that solution do you need to get 1 mole? So this one people got a little mixed up on. They're trying to do M1V1 equals M2V2. And really want to take a step back and just think about this, right? A 5 molar solution means 5 moles in 1 liter. And you need to get 1 mole, right? So if I wanted 5 moles, I would need 1 whole liter. But I don't need 5 moles, right? I only need 1 mole. So we take the 5 moles in 1 liter. We take it across to divide by 1 mole that we're trying to get, right? The moles will cancel out. 1 divided by 5 is 0.2 liters, or 200 milliliters. Another way of thinking about this, if 1 liter is 5 moles, what's 20% of that, or 1 divided by 5? I want 1 mole of 5 mole solution. It's 200 mils. So you need these 200 mils to get that 1 mole. Number 3, the reaction proceeds at 50% yield. What is the amount of the organic product made in milligrams? So again, you got to go back to your limiting reagent. Take your limiting reagent. So 0.25 millimoles, 50% yield, so 0.5. Multiply those, so the reaction is getting proceeding 50% yield. The most we could have made was 0.25 millimoles. 0.5 times 0.25 is 0.125. 0.125 millimoles of C, we got to use the molecular weight of C, which was 75. So 75 milligrams in 1 millimole. Again, grams per mole is what you're used to seeing, but milligrams per millimole is the same ratio. So millimoles will cancel out. 0.125 times 75, 9.4 migs. Again, now we're saying we're in the reaction again. We're collecting 13 milligrams of product. What was the percent yield? So now you take 13%, 13 milligrams. Figure how many millimoles of C that was, right? C is the product, and that was 75 milligrams for 1 millimole. Cancel out your milligrams. You end up with 0.173 millimoles of C. You divide that by 0.25 millimoles, which is the most millimoles we could have made because of the limiting reagent. Take times 100, and it's 69%. Version B was another version. Same process, just different numbers in the thing.